Hello Longhorns, we're going to begin the 5.2 review for our test on Thursday, and the first problem we're going to do is problem number 1, and this is a polynomial subtraction problem. So I'm going to write out the solution for this problem, and then I'll walk you through step by step. Alright, so the first thing I did was I went through and I rewrote this whole, where's my pointer? This whole problem right here. Since this has a minus sign in front of the parentheses, what this means is that I'm going to be subtracting everything that's inside. So when I rewrote this, I went ahead and wrote this as minus a negative, which is the same as plus. So plus 11n minus 2 minus a negative 14n squared, which is plus 14n squared. The next thing I did was combine like terms, starting with the term that has the highest degree. So a negative 7n squared plus 14n squared gives me 7n squared. And then I combined the next term, which was 8n, with 11n, get 19n. And then the negative 4 minus 2, which is a negative 6. And that's all there is. Alright, the next problem I'm going to demonstrate is long division, and I'm going to do problem 4 on the review. Alright, for the polynomial long division, the first thing I did was rewrite my equation so that I could do the division process. And so this part right here is my divisor. And this is my dividend in here, and I'm going to divide that by writing my 3x plus 2 right here, and this part of the polynomial right here that I am dividing up, this needs to be in polynomial order. Right now it's not in polynomial order, so I rewrote it so that it would be in polynomial order, decreasing in degrees. So here I have 12x to the third plus 20x squared plus 11x plus 2. And then I begin the division process. So I need to look at this 3x and this first term, which is 12x to the third. How many times will 3x go into 12x to the third? Or you can look at it as, what number would I need to multiply times 3 and times x to get 12x to the third? Well, I would need to multiply the 3 times the 4 to get 12, and to get x to the third, I would need to multiply this x by x squared. So my first term up here is going to be 4x squared. Now I multiply. 4x squared times 3x gives me my 12x to the third. Then I also have to multiply this 4x squared times 2. 4x squared times 2 is 8x squared. Then I put parentheses around that and I subtract, because I have to subtract both of these terms. This seems to be where we're getting stuck, or we're making a mistake right here. Make sure that you're subtracting both of these terms. So 12x to the third minus 12x to the third, of course, is 0. Then 20x squared minus 8x squared. That leaves me with 12x squared. Then I start that process all over again. 3x goes into 12x squared 4x times. 4x times 3x is 12x squared. And 4x times 2 is 8x. And then, again, parentheses and subtract. So when I subtract here, I end up with 11 minus 8x is 3x. And I drop down my 2, my last number here in my polynomial. So I have 3x plus 2 into 3x plus 2. Well, that's just the number 1. 1 times 3x is 3x. 1 times 2 is 2. And I end up with a 0 remainder. Now, if I had a number here that was not 0, I would then bring that back up to the top, and I would either add or subtract depending on if it's a positive or negative number. And then I would have to divide that number by the divisor. So just make sure that you remember, if you end up with a remainder, that you need to do that. divisor. Okay. All right, the next problem we're going to do is number 8, and this is a synthetic division problem. And so the first thing we're going to do is I'm going to set up the problem for you, and then I will do the division and then walk you through it step by step. All right, with this problem, we're using synthetic division, which is a lot of fun, and we take the coefficients for each one of our terms and make sure that these are in polynomial order. See how this right here is not in polynomial order. So I need to put that in polynomial order first, and then we can do the division. And make sure you don't have any missing terms, because these need to be in polynomial order and descending order, and you need to have a value up here for each term. So you need one for x to the third, one for x squared, one for x, and then one for your constant. So if you're missing any of those, then you need to put a placer in. You would need to put in a 0. Okay, so I have 9 for my x to the third. I have negative 18 for my x squared. I have a negative 16 for my x, and 32 for my constant. And then I'm going to begin my dividing. Now don't forget that you need to change this sign to positive 2, because you have to set this equal to 0 and solve for x. So we're going to be using the number 2. So we're going to divide with the number 2. So the first thing we're going to do is bring this first term straight down. We're not going to do anything to that. We're just going to bring it straight down. Then we're going to do 2 times 9 is 18, and then we're going to add. We'll get a 0. 2 times 0 is 0. Then add. Negative 16. 2 times negative 16 is negative 32. Add, and I have a remainder of 0. All right, so we take our first term. Now this is going to be, since we have x to the third here, this first term we're going to have is going to be an x squared term. Because remember, we divided out one of the x's. So that means that our next term is going to be x squared. So 9x squared, the middle term is 0. The constant is going to be negative 16. And then we don't have any remainder. And that's it. That's all there is for synthetic division. Sorry, excuse me. All right, we're going to do number 10. And in number 10, we need to find the remaining factors. We're also going to do number 11 and number 12. And there's a lot of factoring with these kind of problems when you have to find all the remaining factors. So if you can't factor the problem, then you won't be able to find those remaining factors. So these problems, once you get to the binomial part, you should be able to factor it. Or you may be able to factor by grouping. So let's get started with this problem. I'm going to go ahead and find all the remaining factors, and then I'm going to explain what I did. All right, so first of all, I went ahead and I used this factor right here as one of my divisors. I can divide this polynomial with this binomial. So what I did was I went ahead and I used synthetic division to break this polynomial apart. So I used the negative 5, and I did synthetic division. And what I ended up with was 5x squared minus 4x minus 1. And then I factored this. So I found the factor pairs that multiply to give me 5. And since 5 is prime, it's just going to be 1 and 5. So my two middle terms are going to be negative 5x and 1x. And I did this by grouping. I'm also going to do one using the box method so you can see both methods. And you can use whatever method is easy for you. And then I went ahead and factored out the 5x, and I factored out the 1. So one of my factors is 5x plus 1. The other factor is x minus 1. So that's how I did this problem. You can also group this one up here. You could do by grouping. If you grouped the 5x cubed minus 5 and the 21x squared minus 21x. You could probably group it that way and come up with the same thing, but I think this is the best method to use. I'm going to also show you one with the box method. All right, for problem 11, we're not able to use synthetic division with this problem because of this 2 coefficient in front of the x plus 1. If you look right here, you'll see that this binomial has a coefficient of 2 in front of the x. So we can't use synthetic division with that. We have to use long division. So I'm going to use long division to do this one. And I'm also going to use the box method once we get to the binomial so that you can see what that looks like. Okay, so as you can see here, I've used long division. And when I used the long division, I was able to get this quadratic, 3x squared plus 2x minus 1. So I did the whole long division process. As you can see, I ended up with a 0 remainder, which is great because now I can go ahead and factor this 3x squared plus 2x minus 1. Now I'm going to use the box method this time. So I'm going to go ahead and use the space down here to show you the box method to get the other two factors. Okay, so I've set up my box. I put my first term in the first box and my last term in the last box. And now what I need to find is I need to find these two middle terms. So what I'm looking for is, I'm looking for the factor pairs that will multiply to give me 3. Well, that's just 1 and 3. So those are going to be my middle terms. Now which one's positive and which one's negative depends on the middle term. And the middle term we have here is positive. That means the larger number is going to take that sign. That means my 3x is going to be positive. Now once I have those two middle terms, I'm ready to factor. And I'm going to factor through the box. I'm going to factor these. I'm going to factor these. I'm going to factor this way. And I'm going to factor this way. And when I'm finished, I'm going to have my two resulting factors. Okay, so when I factored through these two boxes had an x in common, so I factored out the x. These two boxes, the only number they have in common is the number 1. This way, I have a 3 and an x in common, so I factored out the 3x. And in this box, I have a negative 1 in common, so I factored out the negative 1. So my two remaining factors besides the 2x plus 1, because that's one of my factors, my two remaining factors are 3x minus 1 and x plus 1. And those are my two remaining factors. All right, for problem 12, we have a new situation, and I want to cover that just briefly with you. I'm not going to complete the whole problem. I'm going to let you do that. But I do want to set this up and show you what happens. Okay, so I did the synthetic division and I ended up with this polynomial 3x cubed plus 10x squared minus 25x. Well, I'm not able to factor this the way we did the others because each one of these terms has a greatest common factor that I need to factor out first. So before I would try to factor this any further, I would go ahead and factor out one of the x's. And then I could factor the the quadratic. I just want to make sure that you understand that if your terms have something in common, you must factor out the greatest common factor first before you try to use the box or the grouping method or anything like that. You need to make sure that you've got your greatest common factor factored out. I'm going to let you do the rest of this one on your own. Okay, in the next set of problems, we're going to find the remaining zeros, and I'm going to do a couple of these for you, and then we'll move on to the next section. All right, in this problem, I've used synthetic division to factor out the 3, and so I divided that out, and I ended up with this quadratic x squared minus 6x plus 10. Now, if I tried to factor this, I would be stuck because this particular quadratic doesn't factor. So if you get a quadratic that doesn't factor, then you're going to have to use the quadratic formula. And you need to have the quadratic formula memorized. I'm not going to give you the quadratic formula on the test. So you need to memorize it. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to memorize it. Okay, you're in pre-AP Algebra 2. That's a formula that you need to memorize. You're going to need it forever and ever, so just memorize it and you'll always have it. So we're going to use that quadratic formula to find the other zeros for this polynomial. Okay, so I used the quadratic formula and I found that my two other zeros were going to be 3 plus or minus I. So I'm not going to walk you through this whole quadratic formula process because you should know how to do this by now. But I can tell you that on the homeworks I noticed that some of you are making mistakes here with the quadratic formula. Be very careful with this discriminant inside here. Make sure that you're getting the correct number. This 36 minus 40 is negative 4. This is going to give me an imaginary number. So the square root of negative 4 is 2i. So once I've got to this point, don't forget that you have to reduce that fraction. So this fraction can be reduced. So 2 divides into each one of these numbers. So I end up with 3 plus or minus I, and those are my other zeros. So I have a 3 plus I, and a 3 minus I. Okay, with problem 15, I'm going to do the same steps again. Actually, I'm going to let you do number 15 on your own. Let me know if you have any trouble with that problem, and bring your questions to class so that we can clarify any questions that you have before the test. But I think you can do this one. I'm going to let you do that one on your own. Okay, problem 17 is a synthetic substitution problem. So the way we set up a synthetic substitution is similar to synthetic division. And so we're actually going to use synthetic division to find our final answer, what happens when we substitute negative 6 in for x. So we can actually use our synthetic division for this, which is pretty cool because it's a real quick way to get the answer without having to plug a bunch of stuff in. Now if you'll notice that our problem has x's and a's, I believe that these are all supposed to be x's. So just change those to x's on your review sheet. I believe those were all supposed to be x's or all supposed to be a's. I don't think we were supposed to have two different variables there. Oh, since this is an a, I bet all of these are supposed to be a's. Let's go ahead and change those. So those are a's. This one should be an a squared as well. Okay, or a to the third. So let's just change that. All right, now let's get started. Okay, so I used synthetic division again, and I just dropped down my 3/2. Then I multiply, add, multiply, add, multiply, add, and at the end, I get the number 2. This is my solution. So you can also check your answer by go ahead and plug in negative 6 into this equation, and you should get a 2 for your answer. And that's all there is to it. These are pretty simple. Okay, problem 20 is a multiplication problem, and we're having to multiply with the imaginary number I. So you just need to remember that I is just the square root of negative 1. So when you multiply those together, the value changes depending on how many i's are there. So let me just cover this very quickly. I by itself is just square root of negative 1. I squared, therefore, is negative 1. I to the third power is going to be a negative I. and then I to the fourth power is going to be positive 1. Okay, so if you can just remember those values, it makes it a little bit easier when you're doing problems like this. So if I multiply this, I'm going to go ahead and distribute this through. And so I'm going to go ahead and multiply this out, and then I'll walk you through it. Okay, let me try to walk you through this. All right, so the first thing I did was distribute the 4i. So 4i times 3i squared is 12i to the third. 4i times a negative 9 is negative 36i squared. 4i times 2 is plus 8i. The next thing I did was distribute the negative 1 all the way through. So negative 1 times 3i squared is negative 3i squared. And notice how I stack these. Negative 1 times a negative 9 is a positive 9i. Negative 1 times 2 is a negative 2. So I stack the common terms together so that it's easier to add them. So then I add them. This comes straight down, 12i to the third. This becomes negative 39i squared. This becomes 17i. And then we just drop down the negative 2. Now because this is I to the third and I squared, that changes the values of these numbers. Because I to the third, remember, is really negative I. So this actually becomes negative 12i. This one here becomes a positive 39 because I squared is a negative 1. So negative 39 times a negative 1 is positive 39. And then we have the 17i and the minus 2. Now I combine like terms because my negative 12i and my 17i can be combined. So I combine them together to make 5i. And I combine the 39 with the negative 2 to make 37. Make sure you're writing this in the correct order. Okay, the real number goes first, the imaginary number goes second. So it's always A plus BI. All right, so for problems 22 and 23, I'm going to work through problem 23. And there's several things we need to do with this particular equation. We need to state the type of polynomial, list the roots, state the y-intercept, and then graph it. So that's a lot to do with one expression. So I'm going to just go ahead and do each one of these things, and then I'll walk you through each step. Okay, so let me just walk you through what I've done here. All right, so the first part, I have to try to figure out if this is an even or an odd function, or a positive or negative. Now this one looks like it's negative because it has a negative 2 in the front. But be careful because it may or may not be negative. Once you multiply these through, this sign might actually change to positive, and that's exactly what happens in this case. So if you're not sure if it's positive or negative, go ahead and graph it and look at the graph on your calculator to see is it going positive or is it going negative. I went ahead and showed you mathematically what happens. We have this negative in front of the 2, so I just kept the negative sign here. And I'm just multiplying the x's together. Now this is a negative x squared. So negative x squared is just going to be x squared. And then here I have a negative 2x to the third power. So I kept the negative 2 and it raised it to the third power. Now this negative sign actually, this negative right in here becomes positive because negative x squared is going to be a positive x. But it's being multiplied by this negative, so that's where this negative comes in. So negative x squared times, and then a negative 2 cubed is negative 8, and then x cubed is x cubed. So we have a negative x squared times a negative 8x cubed, which gives us an 8, positive 8x to the fifth. So this graph actually ends up being a positive, odd polynomial. So be careful though, if you're not sure, and don't confuse yourself. If you're not sure, just go ahead and graph this in the calculator and see which way the ends are going. Are they going up? Are they going down? On the right, to the left, or which way? So you can look at your graph and determine if it's positive or negative. And then of course the the coefficient is going to be whatever the degree is here is going to be your odd or even. All right, so then the zeros, I just set each one of these factors to equal to 0, and I got that I have a 4 as one of my zeros and a 1/2. I'll remember that these are multiplicities, so there's actually two zeros at 4, and there's 3 zeros at 1/2. So when you get ready to graph, you need to remember that this has a multiplicity of 2 and this has a multiplicity of 3. I find the y-intercept by making x 0. So I make x 0 and I solve for y. So when I make x 0, I get -2 times 4 squared times 1 cubed. And that gives me a -32. So my y-intercept is 0, -32. Now I'm ready to graph. Okay, so I've drawn a sketch of this polynomial. It's a pretty rough sketch, but that's okay. We've got all the main parts in here. So the first thing I did was I put in my y-intercept and I put in my critical points here. So I have one at 1/2 and one at 4. This one has a multiplicity of 2. So that means as I come up through my y-intercept and I come up and I hit that 1/2, it has to bounce off and it comes back down. So that's a multiplicity of 2. And then as it comes back up to go through the 4, it does another bounce. Except this time it bounces once, twice, and then goes back up. So that's a multiplicity of 3. So as I go up, I have this 1, 2, comes back up and goes 1, 2, 3, and then back out. So this is an odd positive polynomial. All right, for the next section, we are going to state the type of polynomial and then determine the y-intercept. So I'm going to do number 24. And then I'm going to add another problem at the end here because we didn't have one on the review, and I want to make sure that you understand what to do when you get to this problem on the test. So I'm adding a number 27 to the bottom of this review. All right, so if I were to change my zeros back into the factored form, this one right here, the first one, that -6 would actually be x plus 6. This one is x plus 2, and this one is x minus 1. Now you'll notice that this one has a multiplicity of 1. So it's just to the first degree. This one is also to the first degree. But this one, you'll notice, this one has a bounce. So this one is going to have a multiplicity of 2. That's why for this one, when I did the calculations for the y-intercept, I made sure that I squared that -1. All right, so the numbers we're going to multiply together are this 6 times 2 times a -1 squared. So 6 times 2 times a -1 squared, that equals 12. That's going to be our y-intercept. So our y-intercept right here is 0, 12. Okay, so I've added this problem here, number 27. Sketch a polynomial that has that is odd negative, has one triple root and 2 imaginary roots, and a negative y-intercept. Okay, so this problem has given me a lot of helpful hints. First of all, I know that my y-intercept is negative, so I can just go ahead and pop that in here. I also know that it has one triple root and that it is odd negative. Well, if it's odd negative, that means it's going to be going this way. Okay, up on the left, down on the right. That's what makes it odd negative. Well, if that's happening, then I know that I need to come in from the left, and I'm going to cross the x-axis at least once. And this one says it has a triple root. So as I come down and I hit this x-axis, this is a triple root. So 1, 2, 3, and then I come down. So this root right here, and it doesn't matter what number it is, we just know that it has a triple root or a multiplicity of 3. Okay? It also is going to come through the y-intercept right here, and then it's going to do some stuff over here on the other side. And we know that it has 2 imaginary roots. That means it's not going to touch the x-axis, but it is going to bend. So as it comes up back towards the x-axis, before it touches, it bends back down. And that's what gives us its 2 imaginary roots. Okay, so this point right here would be an imaginary root. And that would be a sketch of the graph. So make sure you can sketch graphs from a verbal description, because that's going to be on the test. And that's the end of our review video. So make sure you do all of the problems on your review. Please do not come to class with an empty review with none of the problems worked out. Do at least one from each section before you come to class on Wednesday. And on Wednesday, we're going to finish the review in class. Good luck on your test, and I hope you all get 105s. There is a bonus question.